Okay, so first, just to talk a little bit about CIE, which is the organization sponsoring tonight's event. Chinese Institute of Engineers was founded in 1917. It's more than 100 years old. Actually, this year it marks the 105th year anniversary of the foundation of CIE USA. The San Francisco chapter, the CIE San Francisco, was actually founded in 1979. So that was also about 43 years ago. The CIE USA is actually made up of altogether about 7 chapters. There's one, besides the one here in San Francisco, there's also a chapter in New Mexico, in Dallas, LA, New York area, Seattle, and also there's OCISA. OCISA is actually a nationwide for environmental, so it's distributed all over the USA. That's OCISA. So altogether, there are 7 chapters. Locally, the San Francisco Bay Area chapter, as I said, was established in 1979. So this year in 2023 is also the 44th year already for the San Francisco chapter. Locally, our chapter is made up of 5 groups. I'm the chair for the Emerging Technologies Group, which is sponsoring this evening's talk. There's also EECS, Electronic Design Technology, Biomedical, and also there's a Young CIE group. There are many activities that the CIE San Francisco chapter is responsible for. We not only have monthly seminars, technical seminars, such as the one this evening. We also have software code study groups, and also have some other events, such as the AAEOI that I'll describe briefly next. So at the bottom of this slide, every year there's a Asian American Engineer of the Year. That's the acronym AAEOI. This is not only for Chinese engineers, but any engineers of Asian descent, Indian, Vietnamese, Korean, Japanese, and so on. And that is in turn organized by the various chapters in the USA. So for people who are in the CIE organization, here's this, you can take a screenshot and get the QR code for both the various line, Facebook, chat, and so on. All right, so you can take a screenshot of this one, and you can also just go to the website and join us. So that's the introduction for the Chinese Institute of Engineers. We're still about a couple minutes away from the actual seminar. We'll start on time at 7 o'clock. So I don't know, for people who don't know me, actually, my name is William Gao. I retired around 2009. I worked in the semiconductor industry, electronic design automation for more than 30 years. I retired around 2009. And I've joined the Chinese Institute of Engineers as a board member. And my passion these days is in technology and education. So for the past 12 or 14 years, I've been given monthly seminars on various technical topics. Previously, as I said, I work in semiconductor and EDA, and I was engineering executive at the various companies such as Texas Instruments, Xerox, and Cadence Design Systems. After I retired, I've been giving monthly seminars, and as well as teaching occasionally at the University of California, Santa Cruz, Silicon Valley chapter. I was also a adjunct professor of EE in the UCLA while I was working in Southern California. In the past 12 or 14 years, I've given actually more than 100 seminars on various topics. When I retired, I moved from semiconductor industry to clean technology. And then after clean technology, right now, my interest is in emerging technologies. Gradually, I found out that the topics I was giving the lectures on no longer were related in the field of clean tech. So when I started giving talks, it was on solar energy, on wind power, on clean water, batteries, and so on. And now these days, the topics I cover are AI, 5G, satellite communications, AR, VR, and so on. So basically, I've moved on. This is actually my third reincarnation. So my first cycle was in semiconductors. Second one was in clean technology. And the third one right now is in emerging technology. So even though I'm retired, I'm still very active. So the last line sort of summarizes my current status. I'm a technology watcher. I'm interested in all kinds of new technologies, especially emerging technologies. So I'm a technology watcher, learner. I learn all the new stuff, and once in a while try to give seminars and teach courses. Okay, so I'm also a teacher. So that's my summary. So hopefully everyone can see the screen. So welcome to this evening's talk. It is going to be on AI and humanoid robots.
Yes, sorry, William, your slides didn't advance. So you are
think could someone from the audience mute your Zoom? Okay. So this is the agenda for this evening. I'm going to start by giving an introduction.
Your slides are not
and talk about the relationship between AI and robotics.
Your slides are not advancing. You're not on presentation. Your slides, they're not advancing. They're not in presentation.
Yeah, William, can you share another screen?
Oh,
like
okay.
You are sharing your own.
So you're not seeing the thing. Okay, sorry. So I'll do a reshare. Okay.
Yeah, share the other screen.
Are you seeing it now? Are you seeing my slides now? Okay, so I assume that everybody is seeing my title slide. AI and humanoid robots.
No, we see all of your slides at once on like a slide sorter screen.
Excuse me?
We can see all of the slides at once. It's like on the slide sorter screen. So we're not seeing one screen. We see all the slides.
Let me go to the okay, are you okay now?
Still the same.
So again, welcome to tonight's seminar event, AI and humanoid robots.
No, your slides are still not seeing.
Can you stop the share and start sharing again? I think we need, William, you need to stop and then
let me do a new share.
Restart. Yeah, please share.
Okay. All right.
Yeah.
Stop share. Let me reshare. Okay.
Yes.
How's the screen right now on everybody's PC? Okay, so
Yeah,
I guess
now
at
we
least locally
just see
here
you.
we're
There's
okay.
you're not sharing yet.
I'm still not sharing. Okay, okay. Is everyone okay now? Sorry for the inconvenience. Okay, so let me restart
All
with
right, we're
agenda.
back to the same one with all the slides.
You see on the other end, it's see all the slides instead of individual ones.
See all the
See
slides?
the whole thing of the whole file that you want to share, but not individual.
Let me see. You sure? Can you see that? Or no?
How's everyone seeing now?
That's
Yeah.
the right one. Thank you.
Okay. Very good, very good. Thank you for the feedback, and I apologize for the problem. Okay, so this is the agenda for tonight's seminar. I'm going to start by talking a little bit about the relationship between AI and robotics. Okay, and then I'm going to start from the beginning, give a brief history about robots, talk about specifically tonight, the topic is going to be on human-shaped robots, so humanoid robots, features, challenges, applications, and so on. Talk about all the components of the humanoid robots, give several examples. I have even some movie videos just to show you what's the current state about robotics today. End up by talking about the future and summarize and conclusion, right? Okay, so I think that AI, of course, has been on everybody's mind since the beginning of since the end of last year. In December of last year, ChatGPT came out, and then everybody, went crazy about AI. Now, the thing with AI is that we're talking about the ChatGPT is actually a large language model. It's actually more like a sort of like a replacement of Wikipedia. We used to go to Wikipedia. We used to go to Google to find information on the internet. Okay. Now the ChatGPT is a different way of accessing information, not by doing a query, but actually chatting with the box. So you do it in terms of question and answer. Okay. So that's ChatGPT. Now the problem with that power of AI is that that's corresponding to the human brain. You're exchanging knowledge and information, okay? But there's more than that. So given all the knowledge, what can you do with it? If you cannot have something that can act on it, you still cannot, it's actually, is knowledge, but not action, right? So that's where robots come in. Robots is actually made up of sensors that can capture the environment and that can act upon it, okay? So wouldn't be nice that not only that the ChatGPT can tell you how to cook a certain dish, but actually you have a robot that can actually cook it for you. So that's the topic of tonight's discussion. So they complement each other, okay? So in the past, we have had robots for a long time, but the definition of robots up to today were really like automation. It's just like machinery. But for example, today in the Tesla car manufacturing plant, there's already robotic arms that can assemble cars, but they do not look like humans. Okay, so the topic for tonight's talk is that a little bit more advanced, where actually not only it is automation, but also you'll be able to live and work with humans in a much better way. So one of the clear examples that if it's not a humanoid robot, for example, a couple of years ago, there was a nuclear disaster in Japan, right? So the Fukushima nuclear disaster, everybody remembers that. And people were trying to go and salvage the disaster. They're trying to go and, get rid of the waste and so on. But people could not go in because the thing was contaminated. And machines could not do anything either, because inside the nuclear plant, they're all like stairs and so on. So the machines could not climb up the stairs. So that's people say, well, if we have the machines that look like humans, that can move like humans, where actually the machines can actually climb up the stairs and do something, and it has also hands, they will cure the problem. So people say, yeah, we really do need not only robots that can help us perform some action, but actually we would like them to be like us, where it is more suitable for the environment, because in the society that we live in, where we climb the stairs, we drive the car, we come to work and so on, is we would like to make the robots the same as the humans, so that it doesn't have the inconveniences that the normal robots have. Okay, so the principle for tonight's talk is that we'll talk about robotic automation, but also we'll talk about human-like capabilities, right? Okay, so let's go back to the beginning and talk about what's the relationship between AI and robotics. So from the scientific and academia, AI is a field of study, okay, where robotics is actually a part of AI. Okay, so if you look at this slide, we have, up to now, people have been learning and listening to seminars on deep learning, machine learning, speech, human vision, computer vision, large language models, big data, expert systems. And out of all these branches of AI, there's one part which is robotics. Okay, so robotics is also a part of AI. Okay. Another slide that captures the relationship is the following. On the right-hand side, you say in the whole domain of AI is made up of the various branches of AI, machine learning, where deep learning, and so on, all these other things that we talked about recently on machine learning. The NLP, for instance, right now, the ChatGPT is actually a large language model. It's based on natural language processing. Okay, so we have speech recognition. Back in the 1980s, there was one time where everybody's looking at AI from the expert systems. That means that people trying to capture a certain knowledge database and call it expert systems. And now that has also changed. Okay, and then you have computer vision. Not only that, but also things like recognition. Like, for instance, people recognize the retina, or even from people's movements, hand patterns, eye retina patterns, and so on. And then there's here, it is also robotics is also a part of AI. So AI is one of about 6 to 7 branches one of the branches of AI is called robotics. Okay, robotics is the actual mechanization and automation part of it. So that's the context of where robotics fit into the whole field of AI. Okay, so let's again start from the talk about a little bit more specific about robotics. So let's go with a talk about robotics and robots, and then later on we talk about humanoid robots. So robotics is the branch of technology that deals with the design, construction, operation, and application of robots. Okay. Now, remember that when robots initially came up, they did not have a human shape. They were just like a mechanized thing, like like an arm, for example, or something like that. That's also called robotics at that time. Okay. So the other thing is that at that time, everything that performed with under automation, you have to pre-program a certain machinery to do certain function. Okay, and right now we with the last newest development in AI, like we saw on ChatGPT, and we are trying to move into an area where it's more general AI. It's still not general AI, but it's almost to the level where it can talk about almost any subject. So it's almost like going to the internet and typing into Wikipedia, and you can type in any question that you want, no matter what the domain is. The other thing is that before AI, up to the most recently, it was specialized in a certain area. Now, for example, way back in the 1960s, there was a machine that knew how to play chess. And remember, they beat the chess grand champion, right? And then recently, in the last 2 years, there's a Go champion that could beat the best Go player, okay? But those are very specialized niche areas where you can make the machine really surpass the human capability, but only in a certain domain. So recently, why everybody get so excited since December of last year is that now suddenly you can ask the AI almost any question. You can ask us, say, write me, and not only that, but it can also be creative. So this is what called generative AI. Generative AI means that it's not just a repository of knowledge, but actually it can create new things. Like for instance, given the keywords, you can actually create a new poetry. You can create a new painting. Say, draw me a car as Picasso would draw it, for example, or Salvador Dali would draw it, okay? So it's actually not only creating something that existed in the past, but it can create some new things. That's why it's called generative AI. So a lot of new things have passed since end of last year. Okay, so robotics, again, is the area where you actually dealt with mechanical part of it. As I said, it's the part where it can actuate, it can act upon it and do something, perform an action, okay? So what's the definition of a robot? So again, this is, I guess, from the traditional concept. There's a Robot Institute of America, okay? And what's the definition of a robot? A robot is a reprogrammable, multifunctional manipulator designed to move material, parts, tools, or special devices. And it can perform a lot of functions that the human can do. So that's what a robot is, the definition of a robot. At that time, robot, it could resemble just a mechanical part, just like an arm, robotic arm. And right now we're getting more advanced, more sophisticated. So we're actually trying to make the robots with the shape and the form and the intelligence of a human. Okay, so that's where we'll be talking about tonight. Now, the term robot, it came from actually with a play in 1920. There's a play that's called Rossum's Universal Robots. And that's where the term robot came from. It's actually from a Czech author that actually wrote this play, okay? So let me show you a little bit more about that. So just to restate again, what is a robot? A robot is a machine, okay? It's a machine capable of executing functions that humans used to do, okay? And they, at that time, the term robot, it did not mean that it had to go and look like a person, okay? It could be just a mechanical arm. Now, for instance, all the assembly parts today in Tesla's car factories, all mechanical arms. But as I'll tell you later on, is that even Elon Musk is trying to make his Mexican car, they're moving the car manufacturing from China to Mexico. They say, well, where are we going to find all the workers? They say, well, we're going to go and create robots, and they are going to be the workers in the Mexican factories. Because in general, I guess usually the Chinese worker is much more, smarter, actually more diligent and so on, right? So they say, well, we're going to find all these people to man your car manufacturing factories in Mexico. Say, well, first thing, I'm going to go and create the workers. I'm going to create an army of robots. And then the robots are going to be assembling the cars in Mexico. So think about it. So I'll show you the work in this area by Tesla and as well as OpenAI on robotics, okay? Okay, so now let's go into from robots to humanoid robots. We already mentioned that humanoid robots means that the robots now have the shape and the form of a human. So that's called humanoid robots. That means that they have a head, they have two arms, they have legs, okay, they can move around. Hopefully inside the head, it has like ChatGPT knowledge. So think about it. It's getting smarter and smarter, okay? And what's the benefit of doing that? As just like in the example I gave about the Fukushima nuclear plant disaster, is that if the robot or whatever is trying to perform a function does not look like a human, it will not be able to navigate in the environment, because the environment that we live in are suitable for people with 2 feet, with 2 legs. We can climb upstairs, we can go down, we can go and drive the car or whatever. Now, if the robot is not in that shape, you cannot do that. You cannot climb up the stairs. For example, up to today, if you're inside your house, you have a Roomba, the one that does the dust cleaning and vacuum cleaning. Right now, you cannot climb the stairs, right? So what happens? You have to go in the stairs. You have to do it yourself. You have to vacuum your stuff yourself. Now, imagine if you have a robot that can do the cleaning. It can not only vacuum the whole thing, but it can actually climb up the stairs and go up to the 2nd level and 3rd level. Okay, so think about that. Okay, so in most of my talks, I try to go and cover the 5 W's and the 1 H. What is it? Why do we need it? Where, who does it? And finally, the H is the how. How do you do it? Okay, so we'll cover all the 9 yards regarding robots and humanoid robots tonight. So why do we need humanoid robots? Again, we're trying to automate things. Like for example, why do we need robots in the factory? It's because right now, today, the humans are doing the assembly. People get sick. People have to go and take a break, okay? And you can work only about 8 hours or 10 hours, so you have to go back and rest, right? Well, robots can work, 24 hours. They don't get tired, right? That's the reason why everything that whenever a machine surpasses a human, there's no hope that the people can catch up. For example, when the AI beat the human Go champion, there's no way from here onwards that a person can beat the machine. Why? Because imagine the AI machine can play 100 games every day against itself, okay? A person can play, maybe 3 or 4 games a day, and then he gets tired, and then say, I'll have to go and eat, I have to go and rest, okay? While the machine is a continuous learning. It never stops, okay? So imagine all the advantage that a machine has over a person. It never gets sick, it doesn't demand a raise, right? All of that, all the benefits about machines. Okay, the other thing that you're going to be realized, especially these days, is that actually, do you know that looking at all, especially in year 2023, there are so many human and as well as natural disasters that actually the population of the earth is no longer going to be increasing, it may be decreasing. You look at how many people have died from the floods, from the fires. Okay, so who's going to do the job? You need to have the people who need assistance and support. Okay, right now, as we all grow older, especially like my generation, we're retired, in a couple of years, we won't be able to move. And then, well, who's going to take care of us? Okay, the elder care, right? So the first application of robots is going to be on elder care. Okay, because right now it's very hard to find people that can help the elder people. So guess what? Definitely in my lifetime, it's going to be a robot that will be taking care of me. When I can no longer move, guess who is going to help me get up? Okay, and so on, right? It's going to be robots. And that's the reason why robots also have to become smarter, and also be more emotional, engaging with people. Okay, the machines need to understand humans better. It's not just receiving commands from the person. So right now, actually, the advances in AI and all these fields is that the machines are becoming much more intelligent, and they're actually even becoming more emotional. They can engage. They can detect where the owner is happy or not happy, just by computer vision, looking at the face of the person. It can determine what's the mood of the person. Okay, so that's very advanced right now. The third point that I'm trying to make here, the hazardous environment. For instance, I gave the example about nuclear waste. You cannot deal with it. A person cannot get in and get exposed to nuclear radiation. The other thing is that in outer space, people cannot survive without a spacesuit. Okay, so you can have a humanoid robot in outer space and do something. They say, well, I don't need oxygen. The machine doesn't need oxygen to breathe. It doesn't have to carry an oxygen tank. Okay, and all that stuff. So it will open up a lot of new applications for humanoid robots. So I already mentioned the first point here in this slide, is a human-like interaction. One of the things that currently in the new technology is the IoT, Internet of Things. Okay. That means that things have to interact with each other as well as it has to interact with humans. So one of the things that we expect out of robots is that the human and robot interaction. Okay. The other thing, the versatility and flexibility. I already mentioned a lot of examples about, the robots, if they are like a people on two legs instead of just wheels. Okay, then things can do just like everything that humans can do, the robots will be able to go and do. Okay. Task adaptation and learning. So this is where all these advances in large language models and creative generative AI is about. As the brain enhances, okay, and becomes smarter, then everything will be moving up. Okay, so we'll talk about in detail all the specifics about, for instance, the head of a robot. The head of the robot will be like a human. It has computer vision that will be able to look at things. You'll be able to hear. Okay. Right now, it's gradually, there's a few senses that are not there yet, like smell, taste. Okay, those are, for instance, you have like the 5 human senses, right? Vision, audio, smell, taste, and touch. So all of this will be coming along. Okay, so let's start from the beginning. Actually, do you know that actually robots have been here in existence for less than 100 years? Actually, it probably started about 1950s. So it's close to about 70 right now, 2020. So we're about 70 years since the first robot came up. And I'll talk about from the beginning. So people who are here and listening to this seminar, you have the whole sausage tonight, okay? So, as I mentioned, the word robot came out from a play, but the person who came up with the term was Karol Čapek, okay? So he was a Czech who actually wrote the play. And inside, there's a thing called robot. The play was called Rossum's Universal Robots. That was in 1921, okay? Now, at that time, there's no actually robots yet. So the robots actually don't start until 1950s. Okay, so 1950 to 2020 is only about 70 years. But guess what? In the next few years, between now, we're 2023, between now and 2030, there's going to be, you won't imagine the advancements that you're going to be seeing. Okay, so I'll talk about that a bit later. So this is actually from the universal word called robot. Inside the US, there's also another writer called Isaac Asimov. So people who are into sci-fi, science fiction, you probably heard about Isaac Asimov. He's one of the most famous science fiction writers, okay? So one of the things that you when you leave tonight and you know enough about robotics to be dangerous, people are going to ask you about the 3 laws of robotics, okay? So if you cannot say what's who came out with the 3 laws of robotics and what are they, that means that you don't know enough about robots, right? So when you walk out of the room today or listen to this webinar tonight, you heard about the 3 laws of robotics. The 3 laws of robotics, this came out in a play by, in a book by Isaac Asimov in 1942. Okay, so the 3 laws of robotics. Number 1, a robot may not injure or harm a person. The first law, okay? Second law, a robot must always obey the orders of humans. And the third one is that a robot also has to be self-preserving, okay? But when you do violate the first 2 laws, that means that according to this, the robot should always be obedient to the person, not trying to harm the person, okay? Because otherwise it will violate actually the law of the robotics, okay? So like all the movies that you see, the Terminator, where actually the robots are killing the people instead of that. It's not supposed to happen, okay? But of course, every time you come out with a law, then there's a movie that come out, you know, that preaching the opposite, right? Okay, so from the last 2 slides, you know where the term robot came about, and also you also learn about the 3 laws of robotics, okay? Okay, so a little bit about the progress and the history about robotics from ancient times, from the Greek up to today. Okay, you're going to hear the whole enchilada, right? So way back even in Greece times, in the Greek times, the first one is called, there's a guy in Greece called Huron, okay? He lived in Alexandria. And he came out with a thing called automaton, okay? So like, think about it. Actually, it sort of like jives with what the task of a robot is, which is automating a lot of the human tasks, okay? Now, the other one that is sort of like a genius that everybody recognizes a human genius because he spans so many domains, like the Mona Lisa, the Last Supper, the trying to invent something like the airplane, so he's a multi-talented person, Leonardo da Vinci. He's probably in the history of mankind, the guy who actually spans many, many domains, from the art to the engineering, okay? So he also designed a robotic knight. You know, back in the medieval, there was the things that look like a knight made of metal, okay? So he put in some pulleys and things like that inside the knight so that the thing actually could move the arms and so on. So we'll talk about it a little bit more. Now, the first robot, this is like human robot, came up in 1970s. Now, this is, I'm jumping a little bit about the first robot was in 1950s, but that was not a humanoid robot. The first humanoid robot was in 1970s, okay? So we'll talk also a little bit about all the various kinds of robots. The robots in Japan, in China, in the US, in England, okay? So a couple of pictures just so that I keep everybody awake, right? So that if you see too much words, you doze off, okay? So the first picture on the left is the first Greek automaton, okay? So that's the first thing that came out. It just sort of looks like something made of metal. On the right, you see the robot knight by Leonardo da Vinci, okay? So a little bit more about it's not just a piece of armor, okay? So inside the robotic knight, there's actually levers and pulleys. So we mentioned about mechanical. The robot is actually something that's mechanical. So you need to be able to move. It's not just a piece of metal, okay? But actually it can move. That's why it's called the thing. So Leonardo came up in 1495. That's in the 15th century. He came out with a robotic knight that it had levers and pulleys inside it, okay? It could wave his arms, raise the visor, open the mouth and so on, okay? So it's actually, if you see on the lower right corner, you see that there's something inside the armor that can actually help it move, okay? Okay, so now, let's jump from the medieval, from the ancient Greek times to the medieval times, Leonardo da Vinci, to the modern times. So the first robot is not a humanoid robot, just a robot, like an arm. You'll see a picture of it, was in 1954. So that's why I say there's about 70 years from the first time that a robot first came out was in 1954, okay? So this is what the thing looked like. So actually, if you look at it, it's not that much different than a, say, Tesla robotic arm that can move, you know, the chassis of the Tesla car from this one station to another station. It's just like a machinery, right? So the first robot, that's why definition of robot is actually evolving as well. Okay, so if you look at it, that's no different than a mechanical arm that you see in a modern factory today. Okay, that's in 1960, 1950. The first humanoid, human-like robot was only from Japan, okay? So it's called Wabot. Why Wabot? Because it was developed by Waseda University. So it's a Waseda University robot, okay? Okay, so let's go back a little bit and then come back to the humanoid robots. So up to today, in all the factories that you see today, the automation is actually done by mechanical arms, okay? So you have industrial arms. Like for instance, this is a picture that you can see on the lower right could be like a car manufacturing plant in Fremont, okay? The Tesla manufacturing plant. They do not look like humans, but they are basically machines that can assemble a car, okay? And they're all pre-programmed. So all the arms are supposed to do only a certain function, but they do not carry like a general knowledge, like for instance, ChatGPT or some of the latest technologies, okay? So a very specialized program, okay? But what would that look like, say, in a few years? why are people so worried about where people will have the jobs? It's because in the not too distant future, this is what it will look like. Inside a new office, there will be people, if you look at that on the lower left corner, the robot will actually be typing on a keyboard. So that will be replacing a lot of the engineers who are doing their work on the PC. Okay, so it's no longer just a mechanical arm putting, you know, car doors on the thing or painting the car. You actually will do brain work. Okay, so, and look at it. Human and the robot will collaborate. So in the workforce, there will be robots in your office. So one of your co-workers may be a robot. Now, it does certain things, okay? And hopefully you also still have a role. So there's a role to be played by humans, and there's a role to be played by robots. So it's a human and robot interaction and collaboration. Okay? So here's a picture where a robot is talking to a lot of people. Okay, maybe the robot knows a certain knowledge that all the other people don't have. Okay, or it can do manufacturing. I'll show you a video of what the robots today can do. So in the workplace. So that's exactly what it will show in this picture, where it will be moving boxes. So today, if you look inside the Amazon, you have people moving the boxes. So say, okay, let me ship this box. Okay, let me get all the orders, put it into a box, put a label and ship it. Okay, all of that will be done by robot in a not too distance. As a matter of fact, that could be done in the next couple of years. Okay, so that's why people will become more worried about, well, what's the role of a human now? Okay, because there are a lot of things that will be done by robots. Okay, so let's dive in a little bit more deeper now into humanoid robots. So this is a little bit like still a engineering seminar. So it's not just for everybody, but we'll be talking about mechanical engineering. We'll be talking about computer vision. We'll talk about AI and so on. Okay. So humanoid robots, they mimic the human form. They look like a human. It has a head, it has two arms, it has a chest, a torso. Okay. Even the arm and the hand of the robots. I'll show you that right now the dexterity of a robotic hand can even play the Rubik's Cube. You know that I was never too good at it. But you know, remember when the Rubik's Cube came out? Is that people can do it in 1 minute. You know, the champions can do the put all the colors in the right place. Well, the hand of a robot can do that. So that you can move the fingers in such a way that I can do the things, very fine things. Okay. So again, the definition of humanoid robots is just a robot that looks like a person, like a human. That's why it's called humanoid robots. You have a head, a torso, 2 legs. So before, a lot of the first generation robots, they were running on wheels or like a tractor belt. Okay, so the way that they will move, the locomotion part of it, it was not like based on 2 legs. It's made based on wheels or on a tractor type of thread. Okay. Not only the general aspects of a body, but if you now zoom into the head, okay, the head of the robots would be resembling a human. You have 2 eyes, you have computer vision. You'll be able to see things, okay? The audio, the ears will be able to listen to speech. The mouth will be able to say words. Okay, so the mouth, the eye, the ears. So right now, the only 2 right now that are not there yet today in 2023, I don't know where it can smell. Okay, our nose can smell things. The other thing is that we have a taste. You know, we enjoy food, right? So one day, maybe the thing will also be able to, and the other one is the touch. Okay, so like for instance, right now, one of our senses to, if you touch something hard or something soft, you can hear. You can feel it, right? So those are all getting there. All will be there. Okay. Now, the robot is made up of two things. One is the sensors. The sensor is where you capture the external data. You listen to a noise, or you listen to data, or you see the thing visually, or you hear it. Okay. Now the other one is made of actuators. The actuator is our hands. So one is that we capture the data. The humans capture the data via the eyes, the ears, the smell, the touch, and so on. And then we have our hands and our legs. Our legs allow us to move around, and our hand and our fingers, our hands, allow us to do things. Okay, so all of that will be in a humanoid robot. So things like, for instance, do you know that out of the sensors in the robot is made up of two components? Maybe you don't think about it, but do you know that in a human, the ear is actually where it gives us the balance. So you don't fall. Okay, it's all inside our inner ear. Okay, so in the humanoid robots, you have two types of sensors. You'll be able to go and now know where you are. So position, just like GPS. GPS tells you, okay, you are here in this conference room. Okay, and then when you stand up, when the humanoid robot stands on one leg, you'll be able to balance. Well, how does a person climb the stairs? Because you have to have balance. Otherwise, how do you move one foot after the next foot and you don't fail? You don't tilt. It's because it has balance. So there are lots of things that go into a robot. There's a lot of technology. Okay, so there's two types of sensors. One is that orientation, balance, and position. And the other one is the vision, the sound, the smell, and so on. Okay, so this is the most typical humanoid robot. It looks like a human. It has a head, it has a body, it has two arms, it has the legs. Okay. And not only that, if you later on, okay, so we already talked a little bit about sensors and actuators. Besides the balance, there's also the pain. Do you feel, like for instance, we talk about the touch. Is that, can you feel that something is hot? Okay. Heat, pain. Okay. Also, if you dive into the face of a humanoid. Okay, so this is like, if you look at the entire robot, start with the head. And inside the head, there's eyes, there's still the ears, there's actually, there's also the robot is be able to enunciate sound, so it has speakers. How do you move? You have to have battery. So a human, what is our battery? We have to go eat food. You have to drink water so we can move, because otherwise you don't have energy. You cannot move around. Well, if it's a robot, you have to have battery. Just like a car. How does a car move? You have to have battery, right? So, and then you have cameras, you have visions in the eyes. Okay, you have something that can listen to sound. Okay, so they're all sensors. Okay, so here, this one is where we talk about a little bit more detail. So this is the head of one of the more advanced robots. Okay, this one is called Sophia. I think it's developed in the UK. So if you look into detail, okay, the eyes of the robot can actually see things. Okay, can detect motion. Okay, the ears can listen to sound. Okay, so eyes and ears are given for granted right now, audio and visual. Okay, but later on, you will have also, okay, the other thing is that the mouse can say something. So right now, all the robots can say things. Right now, ChatGPT, when you interact with ChatGPT, it gives you the answer either in text form or you can do it with words, right? And there there are some other ones that will be coming, that smell and taste. Okay, but it's actually pretty complete. It's going to be pretty complete. Okay. Okay, so again, if you analyze the whole anatomy of a robot, you have the head, you have the torso, you have the limbs, the arms that can move. Okay, and then the other thing that right now people are the most excited is that what goes into the head. There's also a brain. Okay, so in our head, it's not only just the eyes and the ears and things that, but also our intelligence goes in there. So now with advances in AI, with the knowledge, so a lot of the robots that I'll show you later on, they already have ChatGPT integrated in there. So think about it. It's not just the knowledge. It's actually, hopefully, it's also in a body that can move. Okay. Now there's still a long ways to go. I'll talk about in my last slide on conclusion. But anyway, so one of the things that people are most excited about is the advanced AI. How advanced is the computer vision in your eyes? Okay. How good is your speech? Okay. And also right now today, a lot of the ChatGPT is already more advanced than humans because it can speak in many languages. It can go and translate from one language to another language. Okay. Okay. So here's some examples. Just again, I'll alternate between text and pictures. So if you look at this picture, it shows how the robot is coming down the stairs. That is called the mobility. It's done with bipedal. It's done with 2 legs rather than wheels. Okay. So it can move in the environment that we live in. Okay. The brain right now, that's going to be like embedded with ChatGPT and all the knowledge that all the AI will have. Okay, this one is where I'm talking about the hand of a robot can actually solve Rubik's Cube. So it moves the fingers with the dexterity that is actually resembles the human hand. Okay. Also, the face will have expressions. So just like the robotic eyes will be able to detect where the human is happy or sad, the face of a robot can also express. Let's say, okay, I feel okay, or I feel sad, or I don't feel good. Okay, so you'll also be able to express some emotion. Okay. The other thing that is important is the interaction between the human and the robot. Okay. So right now, even today, even among people, between people, you see that there's a lot of things that really the people are not really communicating as good. So in the future, the same type of issue will exist. Is that between the humans and the robots, there's need to be understanding and communication. Okay. So some of the achievements. Okay, I think I need to move a little bit faster. So a lot of the achievements and progress. One is that there's a lot of advances in bipedal locomotion. That means that now you have legs that can move up and down the stairs. You can walk, you can run, and so on. I'll show you a picture of what the robots can do right now. I'm actually amazed. They can do backflips and so on. Things that even humans, not all humans can do. Okay, and then human-robot interaction. Okay, so as I mentioned, sensor integration and perception is one of the achievements that we've made a lot of inroads. So what are all the sensors that we have? We have sight, sound, taste, smell, touch, balance, and so on. Okay, so a lot of these have been accomplished actually today. So like everything that's mechanical, we mentioned already earlier about the importance about power and energy management. So if you don't have a battery, the robot doesn't move. Just like, for instance, right now your phone runs out of electricity, you can no longer work. So the battery is still important. Okay. And then the ones that were making leaps and and jumps right now is in the cognitive capabilities. They're going to be, things are becoming smarter and smarter. I think there are some limitations in today's AI because today's AI is based on LLMs, it's on large language models. It's not really based on reasoning. So the current trend of the AI, it will not get us to the general AI because right now it's based on language. You give it 2 or 3 words and you come up with the next word. But it's actually based on language. It's not based on data that you see, and it's not based on rational intelligence. Okay. So anyway, I'll be able to answer any question that you may have on AI as well. Okay. So applications. We already mentioned that healthcare, especially for the elderly, you need more and more people. So actually, if you look at the trend in the past 20, 30 years, remember in China, there's like one-child policy. So you have a lot of elderly people, you have less and less people who can actually support them. Because the young people now, they are being limited in terms of how many kids a family can have. So then you're going to require something to help the elderly, right? Because you have, what, four grandparents, then you have 2 parents, and then you have 1 kid, and 1 kid has to go support everybody else. Okay, so some of the most immediate applications are going to be in the medical and elderly care. There's also like search and rescue, like for instance, disasters. Like for instance, right now, you turn on the TV, Morocco earthquake. Can the human go and lift all the tons of concrete? Can you do it? Cannot do it. So you need to have, how do you have, if you can have an army of robots, it wouldn't be nice. They have actually strength stronger than people. They can lift the bricks and things. It can also detect sounds that maybe people cannot hear, and so on. Education is also can be affected by robotics. Okay, so just to quickly go over healthcare and medical assistance, that will be the initial focus on robots. It will be for healthcare and medical. Okay, education and research. Right now, you cannot find good teachers. And also all the knowledge, if you can put all the knowledge in a robot and use a robot that looks like a person to teach the kids, rather than just a machine that the kids don't know how to interact with. Wouldn't it be nice to have a friendly robot that can be like a teacher to a lot of the kids? Okay. Entertainment, companionship. So right now people say, oh, why do they like ChatGPT so much? Because now if they don't have a friend that can talk over the phone, they can go and talk to ChatGPT and keep interacting. Okay. Also, manufacturing and automation. We already talked about all the factories we've manned by robots. Okay, so let me quickly go over the examples of the humanoid robots. The first one that was famous was the Japanese robot called ASIMO. Okay, ASIMO, Advanced Step in Innovative Mobility. Okay, so it looks like a person. The face does not have the eyes and the ears yet, but it has a head. It has the arms, it has the hand and the legs. Okay, and he had bipedal, the 2 legs motion, balance, agility, and so on. The one of the US most famous is the Boston Dynamics. It's called Atlas. Okay, so let me just skip this slide and jump directly into a video of what Atlas can do. Look at how he can step through things. Look at how he can move across the incline. He can do flat backflips. So look at that agility. Look. All of that is today. It's not like in the future. Can go up and down. Look, can jump over obstacles. You'll be able to do backflips. So look at how the progress has been. Not everybody is aware of it. Okay, now let's go and talk about another one. This is Sophia. Sophia is the one that where it had the expression. So again, I'm going to jump over this slide just to show you a live demo of the facial, what the face of a robot can do and do that. Okay, Amica is another one that is very famous right now. Okay, this is from the UK. Okay, so let me just play this video. You see the mouse is moving, sound is emitting, the eyes move, the head moves. Maybe the sound is not good enough, but if you guys can watch it on your own PC, just type Amica is the name of the robots by Engineer Arts. Look at the eyes moving. Look at the mouth moving, head moving. And also you can reply to questions that people can ask directly, not pre-programmed. So this is the current state of what in a face of a robot can do. Look at the emotion, how the eyes move. Whenever he has a question, he moves in a certain way. So look at the role of this robot. In the future, if you go to a customer service, you don't need a person to tell you, go to a bank, you say, okay, I want to do this, that. All this can be done by a robot. Because it can actually listen to the request from the user, it can do all this stuff. Okay, I apologize again for the sound, but that's okay. So I mentioned that right now the two hottest companies in AI are what? One is, of course, Microsoft and ChatGPT, OpenAI, right? If you think about it, the way that originally Tesla got into the EV, they're trying to make the electric vehicle the next platform. That right now we use the cell phone. We do everything with the cell phone. Right? People, well, Elon Musk say, well, I'm going to make the EV the next platform. You can do everything via the electric car. Okay, so I mentioned that how is Tesla going to build the next EV? It's going to be using an army of robots inside the factory. Okay, so if you look at the characteristics of this, you know, it's 5 feet 8 inches tall, weigh about 125 pounds. You can carry a total weight of 45 pounds. You can move at the speed of 5 miles per hour. All of this is, and it looks like a person. Now you're going to see that depending on the need, the head of the robot, it can be different. Because some of them, you don't need to have all of the robots have eyes and nose and whatever. It depends on what the function of what you want the robot to do. Okay. Okay, so the other one, the other company, OpenAI, is the one that came up with ChatGPT. They're also working on with another company called Robotics, a Norwegian company. So they're coming up with the robots. This is the way that their robot looks like. Okay, again, this robot, it doesn't have the eye, it just has like a head and the mask. Okay, because the function that it's supposed to do is just to lift boxes and so on. So it doesn't need to have the computer vision and everything that goes with the eye. Okay. So before, this is the next generation. The first generation of this robot is called Eve. Now Eve used to be based on wheels. The motion was based on wheels, and then they're going to move it to legs again because that's the trend. The trend is moving to a humanoid. Okay. Okay. Now China is also coming out with a mass-produced robot, and their emphasis is on caregiving. So this is a company based in Shanghai. Okay, supposed to be able to lift people up and carry older people up and down. Okay, get them out of bed and so on. Okay, so it depends. So this is a company based in Shanghai called Fourier Intelligence. Okay, and they are being mass produced. So they're going to make all this not only one at a time. They're going to come out with several hundreds and thousands of these caregivers. Okay, this is another one. This is a U.S. base. The company is called Aptronics. It's based in Austin, Texas. Okay, again, if you look at the characteristics, 5 feet 8 inches tall, weighs 160 pounds, can lift up to 55 pounds. Okay, currently is capable of lifting and loading boxes and so on. So right now, this is actually being used in a factory, just like what Amazon Supply Factory does. So let me just quickly jump into the next slide and show you an example of what it does. This is Apollo. So you look at the legs moving. Carry boxes. You can stack up boxes. The battery runs for 4 hours. Actually, right now, one of the main limitations is still the battery, no matter where it's EV or whatever. The battery technology is only up to run. Look at what it does. Moves boxes, piles up boxes. It retrieves things, just like what a typical Amazon worker does today. Goes and takes the order, lifts put it all together and ship it. So all this is today. It's not like in the future. It actually already does it today. Look at the dexterity of the hand. So if you're interested, you can go and do your own, search. The company is called Aptronics. Okay. Okay. So let me dive into the last 5 minutes of the talk. Future, summary, and conclusion. Okay. What do we envision the future? Every family probably will have a robot. Now that robot that we have in the family will probably help us do with the family chores, hopefully cleaning up the house. If their technology is advanced enough, maybe it can cook a meal for us, things like that. Okay. Will help be able to take care of children, be able to take care of the elderly. Okay. Robots will be able to perform surgery. This is where nanorobots. You know what is a nanorobots? Nanorobots is a small molecular robot that can be injected into our blood vessels, and they can do the surgery inside the body. That's called microsurgery. So it's a nanobot. Nano means 10 to the minus 9, so very tiny robot. Okay. So, but a lot of that, there was a movie, I think that was made in the 1960s called Fantastic Voyage. It talks about a small submarine of experts, and they are injected into the blood veins, and they will go and perform a surgery inside the human body. That's a sci-fi movie. Okay, and then hopefully the brains of that will be also be progressive. Look at the speed of all the knowledge that we have since December of last year. Okay. Now, the robots will have an impact on the employment and workforce. We already saw a lot of slides where I already showed the robots in the workplace will be able to do a lot of manual labor. Okay, and who knows, maybe in the future, you have people working even not only in manual labor, but also in the office. No, white collar job. Actually, you have a co-worker, and instead of being all engineers, you have another robot that's in the middle that has a certain function. Okay, now, what are some of the concerns? Privacy and data security. And this is across the whole domain of AI and cybersecurity. Every time right now, people say that data is the new oil. So, but who does the data belong to? Mostly belongs to us, right? It's not owned by Google or the company who owns the data or the companies that own the cloud. If it's our personal information, we don't have our personal data being used elsewhere, okay, unless it's with our consent, right? So privacy and data security. The other thing is that, you know, the main concern that people have about AI is that AI is probably will become the most powerful tool. Like today, we're in the US, we're worried about guns because people can buy a gun and they can start killing people. Now, with a gun, you can just kill the people who you can see. You can shoot within the distance. With AI, you can commit fraud. You can steal somebody's data from people in China across the world. So the tool is 1,000 times more powerful than a regular tool that you see like a gun. Okay, so that's people who are worried about AI. Okay, if you use AI knowledge to manufacture a bio-germ warfare, okay, you can kill thousands of people. Okay, so the ethical, you have to have with every advance in technology, you need to have regulations and you have to have ethics imparted in there, because otherwise you lose control. So for every technology, there's a good part and there's also a liability part. So you have to minimize the risks, okay? Okay, so technology advancements, future of robots. Well, the thing is in autopilot, you know, you cannot stop it right now. The advances in the AI will keep going, leaps and bounds, okay? Now, the thing that is important, again, is that working the human, how does the human work with the robots? Okay, so in order for robots to help the humans, you need to establish the connection between the humans and the robots, okay? And the application will grow, okay? We mentioned already about disasters, you know, how to you go and help and into areas that the human cannot work, like is radiation, or is it too dangerous, or, you know, like for instance, the humans, they have only so much strength to lift the concrete blocks, okay? If you have a robot, it's like a mechanical thing. Maybe you can lift much more heavy weights, right? You can go to outer space. You don't need oxygen. You can explore other planets where a human cannot survive in another environment. Say going to Mars. Well, the human cannot survive over there. There's no water, no air, whatever. Well, maybe you can send the robot, okay? So there's a lot of improvements that still need to be done. The dexterity will have to be improved. The cognition, that's actually the AI brain part of it. Not only that, but people talk about IQ and EQ, is that if you can impart into a robot emotional understanding. And also you have ethics. You need to be able to teach a robot what's good versus what's evil. And I'll be open to discuss any of these things, into the discussion part of it. And the society integration. So robots, just like IoT, Internet of Things, you have a new device. How does that new device interact with other devices? Okay, so robots have to interact with things. You have to interact with humans and so on. Okay. Last slide, summary and conclusions. If you look at the whole history of the robots from 1950s to present day, it's about 70 years. Okay, robots have come a long way. So from the things that were just mechanical things to, you already saw some of the things that the robots today can do. It can have expressions, it can lift things, do things inside the office. But they all still have long ways to go. Okay, so there are still senses that are not covered. The smell, the touch, okay, the taste. And the other thing is to be able to teach. So think about AI this way. AI is like a brain. But what does the brain do? Is that, for instance, when we raise our kids and we teach our kids, okay, this is a good thing, this is a bad thing. We teach morals, we teach ethics, okay? Well, the same thing, AI is a brain. How do you make sure that it doesn't do bad things? My answer is that you have to deal with it the same as you are educating your kid. You have to go and train the robot and the AI to do things that are good. Okay, so it's part of it's what they call reinforcement learning. If you do certain things, you say, oh, this is bad, next time don't do it. Okay, just like when we teach our kids, you do something bad, okay, you teach it, okay, next time you shouldn't be doing that. The way to prevent AI to go haywire is to be able to, along the line, keep educating the AI brain, just like you're raising the kids and you're training the human brain. You have to go and teach the mechanical brain, okay? Okay, so that's the end of my talk. Now, before I open up for Q&A, I want to give a quick sort of like a preview. If I'm still around here next month, this will be my next talk, okay? My next talk is going to be titled 2023 Emerging Technologies, okay? It's probably somewhere in the October 11 or 12 time frame. You'll be receiving some notices in the email. And what that will cover is the following. Every August of every year, there's a company called Gartner Research. They do a survey of whole industry, of all areas of tech, and they come out with the top 25 technologies for that year. For 2023, it just came out in August. So it came out just last month. Okay, so they map it into what they call the hype cycle. Hype cycle means that you have a trigger, you have a peak, and then you have a valley, and then you have a steady state. Okay, so this is what will be covered in the 25 technologies that I'll be talking about in October. Okay, there are four major themes. The four major themes. And so for people who are interested in AI, one of the hottest areas, of course, in 2023 is called emergent AI. So generative AI, AI simulation, causal AI, federated machine learning, symbolic AI, reinforcement learning, generative cybersecurity AI, all that's related to AI. But AI is not the only technology in 2023. Things are also moving around the cloud. Okay, so there are a lot of cloud-related technologies. There's also a lot of concern about human-centric security and privacy. So right now, one of the areas where there's a lot of startups in Silicon Valley is on cybersecurity, right? Data privacy, data security. And also enhancing developers' AI, okay, developers extension, enhancing developers technology, okay? So altogether, if you add up all this, 7 and 7, 14, plus 6 is 20, plus 5 is 25. There are 25 technologies I'll be covering in the next month. So if people who are interested, you're welcome to come here or attend the Zoom. And then the 4 major themes for 2023, one is emerging AI, one is enhancing developers environment, pervasive cloud, and the last is human-centric security and privacy. Okay, so that's tonight's topic. I don't know where we're able to look at also. Well, we'll first ask for any questions or comments from the in-person audience. Okay.
I have a question. How close is the AI will be able to do, say, dental surgeries or oral surgery? How close is it doing?
Okay, so in general, when people talk about what's the how far away is AI, there's a thing called GAI, called generic AI. Okay, that's going to be far away. That's going to be at least 10, 15 years. But the things that you're talking about will be very short term. You know, for instance, doing operations like surgery, they are very specialized areas. Those will come up way before.
But in the dental field, I am a dentist.
Okay.
And the reason I came here was kind of, there's some, like, so I'm just curious, it would be, after my retirement, but I just want to learn when you. Yeah, so job replacement, exactly. So anyway, there's emotional detection in patients feeling pain or not, and patients not sedated, like doing medical surgery, right? They around unless you completely knock them out, which I don't think the case most of the case. So there are some difficulties, but I know that could be done. And also another thing is sterilization. The robot arms, how you sterilize it.
Anesthesia.
Huh?
Anesthesia.
Right. And all that. And how
so let me answer actually. That question is actually, so some surgeries, you probably have heard about remote surgery. So there's not enough specialists in the world. Let's say that there's somebody who has a disease and he lives in Africa. Yeah. Well, the only expert in the world lives in New York. Yeah. Well, how is he going to do an operation, across the continent? Yeah. So this is what we call remote surgery. So a lot of stuff where you actually have the mechanical apparatus set up in Africa, the doctor is actually still in New York, and he can actually move things, and then there are mechanical arms that can do it.
So the patient's sedated. The patient's completely knocked down. They're motionless. Right.
So my answer to your question is the following: for very specialized and narrow areas, the technology is there to do it. The one kind or two kind. But if you're saying, well, if I'm a dentist and then, well, am I going to be out of the job, in the next 5 to 10 years? Very hardly, because there's not going to be that many. So imagine how many dentists are there in the world. I mean, even in Silicon Valley, you open up the thing, there are probably like hundreds of dentists, right? Yeah. So we're not going to be replacing that. All of that is going to take time. But if you say narrow technology, that people say, can I do a certain operation like on a dental thing? They'll be able to do it. But that's a one of a kind. It's not generalized. It's not democratized, right? So for now, you don't need to worry. Okay. So that's hopefully the question that you have. Any other questions before? I don't know where Christina can help me with some of the questions from online, but so if somebody sends a question,
can we ask
people online can send a chat question via chat to Christina. Christina can just tell me. Yeah, okay. By the way, tonight's topic is called artificial intelligence and robotics. My focus tonight was actually on the robotics part of it. But actually, I've read just about anything there is about AI. So if you have questions about AI, generative AI, ChatGPT, prompt engineering, I'll be able to answer that question as well. Okay. Yeah.
Yeah. What's like the transformation?
But what's like a good place to learn more about the robotic,
Okay. So you know that we live in the era of big data. Big data is defined as there's so much data. Everything is actually on the internet. You can find anything on the internet. The only problem of big data is the following. The quality is very uneven. There's a lot of good stuff. There's also some really bad things that not worth the time. Okay. There are a lot of courses online that if you go and say, oh, can I learn about generative AI and can I learn about all the latest deep learning methods? So there are courses from Stanford, from Coursera, from everywhere, from CMU, from Stanford. But, and this is a big but, is that the quality is just varies all over the place. Some of them you open up, you cannot understand the instructor, because the English is actually so poor. You cannot understand, the accent is so strong that I just tune it off. I said, forget it. But don't give up and keep looking. There are some good stuff. There are some that are too elementary. And there are some that are way too deep. So you need to find. So let me tell you my personal experience. When after ChatGPT came out in November of last year, well, I'm retired, so I'm a little bit different. So I have plenty of time. And I'm also a fast reader. I can read things real fast and learn things very fast. So I've just about read everything about there is on AI. If you go and look at under YouTube, there's also YouTube. There's also the text things that I read in articles and all that stuff. There's so much material, but you have to go and find the things that is suitable for you, because every person is different. Okay. So one thing that I keep telling my friends is that when I did my PhD, I took all the mathematics curriculum, from real analysis to complex variables. And I never used it. In all my whole career, I never used it. I even never used calculus in my career. The only thing I used in actual work was algebra, trigonometry, and geometry. Okay? But guess what? Now that I go and take a course on machine learning about all this, the things, I said, well, actually, I didn't waste my time, because way back when I was in grad school, I took all the matrix algebra. So guess what? Right now, all this, the latest on LLM, this all matrix manipulation. So if you never had matrix algebra, how are you going to go and understand that? So right now, I consider myself lucky that after so many years of not being able to leveraging the things that I learned in grad school, now actually I can pick up any courses online. I can understand all the matrix algebra, vector rotation, vector algebra, matrices, how they do that. How do they figure out all the pixels and everything. And now I say, oh, well, now I understand everything that they say. Now, when you were going to school, you did not take all this stuff. Imagine you have to go and take a course first on matrix algebra and on all that stuff. It's going to be very hard. Okay. But the salvation, coming to the good part of the thing. These days, the way that AI is done, you don't need to be a mathematician, and you don't need to be a AI expert knowing all the machine learning algorithms, because the way that they are presented, for instance, the ChatGPT is an example. You ask a question just in common layman's term. You say, could you explain to me quantum mechanics to a 14-year-old? Okay, I will do it. So, can you explain to me as a college professor to a guy who is writing a PhD thesis on quantum computing? You can't do that. So the levels is really adjust to what you need. So just like, for instance, most of everybody here drives a car, but how many of us can fix the engine if it's broken? Not many people can. So AI is the same. You don't need to be an expert in AI to use AI. Okay, because everything is democratized. Everything is adjusted to what you can do. So everybody can use AI. You can ask ChatGPT a question, say, okay, could you tell me about this? You never took a course in machine learning, right? But you can ask the question. So don't worry about, where you need to catch up with all the mathematics that's behind. Those are the people who are actually getting their PhDs in AI. But you can still leverage and make use of everything that is out there. Yeah, Howard.
So you mentioned on this humanoid attack robot. I'm wondering how many of those are really in use now. For example, Amazon or even Walmart, they store food that they use. Then to replace all those low-wage workers.
That's right.
Are they
So today,
Yeah.
today, I would say today, they are not using the bipedal locomotion yet.
Not yet.
Because imagine right now, for instance, if you need a robot in Walmart or in Amazon to just move things, you can just have wheels. You don't need to have people moving in 2 legs.
Okay.
Right? So it depends. So one of the other things about conclusion, let me come back to the screen. So just in case people are watching the screen, there will be all kinds of robots. If you look at today, let me draw an analogy. If you look at the cars today, there's the passenger car, there's SUV, there's a truck, there's a trailer, all kinds of cars, okay? Robots will be also all kinds. Not every single robot has to have 2 legs. Some of the things that are working in Amazon environment, they just need to work on wheels. They don't need to have legs. But if you want something to climb steps, you need to have bipedal, right? The same thing, if you look at robots, if you look at the head portion of the robot, it changes. Some of them just has a head, but it doesn't have an eye and the nose and the mouth, okay? Because the function is not to speak or not to go and read the lips of the human. So you don't need to. So for things that, for robots that are assembling cars, they don't need to go and talk to the robot next to it. So you're saying, okay, well, I'm going to assemble the door, and then the next guy is going to paint the car. They don't need to have communication. So the head could be rudimentary. So just like in cars, you have cars that are sports cars that can run, 150 miles an hour, but not every car needs to go at that speed. Then you have a big trailer trucks, right? And then you have tractors, and then you have SUVs, and then you have passenger cars, and you have small cars. So robots will be all kinds of variety. So don't try to generalize that every single robot is going to have a head with an eye that can read the thing, can read your emotion, whatever. Those are the robots that can become like a trained psychiatrist. Then you need to understand human emotions and understand people. There are robots for every type of jobs. And right, so you just like today, you have different kinds of things. Like for instance, that we mentioned about the dentist. There are some that just say, okay, well, there are some dentists or some assistants that just do cleaning. Okay, there are some others that need to do root canal. They have to be really specialized. So you have a variety of levels. Okay, so not everything has to be to the top level. So let me give you the example. Way back in the ChatGPT, when it first came out, the reason why everybody got so excited is that, oh, I can also make use of ChatGPT. I'm a guy who is doing accounting. Oh, I'm a programmer, and now I can also use that. Before, everything was specialized. The AI that can play chess, or the AI that can play Go, the only thing you could do is to do that. It was very narrow. It's called narrow AI. Okay. Now with ChatGPT, suddenly say, oh, everybody can make use of ChatGPT. I can, my English is not that good. Maybe I can ask it to write a composition for me. Okay. I'm not a good artist, so let me ask the thing to draw a picture for me. So everybody's needs is different. Okay, so it comes back to the human robot collaboration. Things that you do well, you don't need a robot because you probably are still doing a little bit better than the robot. When the ChatGPT initially came out, I was testing a ChatGPT. I say, well, at that time, when it first came out, it was about at the level of a high school student, okay? You'll be able to answer some general questions like Wikipedia, but if I'm an expert in, I don't know, nuclear fusion, I will ask a question that ChatGPT will not be at my level because I'm the expert that the knowledge is not embedded into their knowledge database yet. Okay, so a guy who is doing advanced research in a certain field, the knowledge is still in the human's head. It's still not passed on to all the LLMs that you do the training for everything. So it all depends. And that's one of the other lessons that are left for thought, food for thought. There's always, in my last slides, there's always a food for thought. What we need to do, we as a humans need to do is that we need to understand what we are good for. What are we good at? Okay. And say, well, I don't need ChatGPT to tell me. For instance, presentations, I could ask ChatGPT just create the presentation for all the talk today. But I say, actually, I've been doing it for 10, 11 years. I can do it faster and exactly to the things that I need. I can go and find all the pictures I need as fast as ChatGPT can. ChatGPT can give you suggestions. Say, oh, Bill, when you write, for instance, I actually, whenever I do a presentation, I start by asking ChatGPT, say, I'm going to give a talk on this subject. Could you prepare an outline? Or first I tell you, say, I want to cover the following subtopics. Could you help me create 20 slides or 30 slides? Okay, with the title. And then the first part is it will give you the title of all the 20, 30 slides. And then you go and say, now fill the content. Because when you come out with the thing, you already have some reference as to what to put in this slide. But today, I'm actually better at doing that. For the subject matters that I talk about, I'm still better than ChatGPT because I don't need to go and tell all the things that I need from it. I know exactly what I need. And I can go and find all the data, the graphics, all the things that I show you today, the pictures. By the way, all this is not done through ChatGPT. All the slides that were done where you see the thing and then suddenly you have automation from the Greek times, and then you have the thing from Leonardo da Vinci and whatever. Do you think that there's a slide that ChatGPT can create with all the across the eras and everything? No. It can do it for you if you tell, okay, create me a slide with Heron from the automaton from Heron and Robert Knight from Leonardo and Asimov from Honda. Yeah, but you have to spell it out. I say, well, by the time I need to go and tell it to produce the thing I want, I do it much faster than time. Okay, so coming back to the thing, we as humans, in order to survive the technology, whatever was AI or whatever it comes next, we need to know ourselves. What are we good at? And we don't need help. And then what the reciprocal is that what are we not good at? For instance, let's say that I'm not a great cook. Okay, I just eat anything, and as long as I'm full, I'm happy. So probably in the future, if there's a robot cook, I probably would need it because it can help me clean the house. It can help me cook because those are things that I'm not good at. So when we go forward, the first thing we need to do is to know ourselves. What are we good at? And we don't need necessary help. And what we are not good at. Okay, these are areas where I could use some help. Okay, so that's always the lesson that I always give at the end of any lectures I give, is that there's always food for thought. Okay, so I don't know is there any other question? Yeah. Yeah. Let me ask her.
So first question is confusing. So you mentioned ChatGPT requires about 361782X, A100 servers, and each server is known to consume about 300 watts,
Right.
or more than a megawatt of power.
Mhm.
So, what real advantages in computers are required to squeeze this into a rocket with the power to run it?
Okay, actually, I know the question, what the question is about. Do you know that even though we have ChatGPT and it looks like it has the knowledge of the past 50 years, capture all in their database, just like the person who asked the question. You know how long it took and how much compute power it took to embed all that stuff into the ChatGPT? It took a lot of NVIDIA, H100s and whatever, all this hardware to be able to run. And so the good and the bad things about it. The good news is that we're not going to see AI suddenly become rampant. Why? Because it takes so much compute power. Just like when everybody remember Bitcoin. When Bitcoin came out, people say, well, let me go and do the mining. Well, you know how much computer runtime you need to order to find the decipher, decrypt the stuff? It takes a cloud computer to do it. Okay, so everything that you mentioned, the person that says is that right now there's probably less than 10 companies in the world that can afford to do the database, build the database for all the ChatGPT knowledge. There's a Microsoft, there's a Google, Meta, right? There's a Baidu or the Tencent, or there's only less than 10 companies in the world who has the compute resources to be able to build all that stuff. Okay, so, but just to the second part of the answer to the question. So first of all, it requires tons of compute power that none of us, that's why we have the cloud. Because imagine that if we all need the compute power that is available in the Yahoo and the Amazon, nobody can afford it, right? So that's why they moved that compute and the storage into the cloud. Okay. But the saving grace is the following. When we embed some knowledge into a robot, really it's an overkill to try to build all the knowledge. So imagine, let me just give you an analogy. When each one of us, we have our own domain of knowledge, our expertise. Not everybody is also an AI expert and also needs how to fix a car and also need to be a great cook and can paint like Salvador Dali and all that stuff. We all have narrow areas. So when we build a robot in the future, it's an overkill to have all the knowledge of ChatGPT. It's almost like having the knowledge of whole Wikipedia for something that you don't really need to know everything under the earth. Okay, you need only specific knowledge. Like for instance, that's why when we go and do Wikipedia or do a Google search, we look for things that we are interested and we don't know. But we don't go and say, oh, tell me, by the way, also how far are we from Alpha Centauri? Or tell me also about how small is the ant. Because for now, we cannot do everything at the same time. Okay, so the answer to that is that yes, the first part is yes, it does require a lot of compute power. But second part is that achieving a general AI robot is way, way far away. But we don't need that because we need immediately what we need right now. Maybe a robot that can help clean the house, a robot that can climb the stairs and also take care of the elderly. That's what we need. But not everybody needs everything. That's the answer. Okay. I don't know whether to say any other question. Okay, go ahead.
Do you think applications such as eldercare might get partially developed, but still before full commercial viability? Like for example, what we're seeing right now with full self-driving cars.
Again, what was the connection between eldercare and the driving?
Yeah, so do you think applications such as eldercare might get partially developed, but before full commercial viability, like for example, what we're seeing today with all the self-driving cars?
Okay, so let me decouple the question a little. everything is being worked in parallel. There are companies who will develop robots that will focus on elder care and healthcare. So those need to have some medical knowledge, need to be able to help the elder people to get up and move around and things like that. But there are other companies that will still be working on self-driving cars. So it's not what they call it, it's not exclusive. It's that there will be companies working on different domains. Okay, so there's not one priority or another. The priority is actually determined by the consumer. So if there's more elderly people who need care than people who need a self-driving car, the demand and supply will determine that. So if there are more people who need care than people say, well, I'm basically old and I don't need a self-driving car. I need to have a company like Uber that can come pick me up and that's it. I don't care where the car that, as a matter of fact, not only in terms of the cars, I gave a talk on that too. The way that the use model is going to be changing. So before in the past, we used to own cars. Okay, so I say, what's the next car that I buy? Do I buy an electric car or do I buy a hybrid? Okay, well, the next thing right now, the trend right now is to don't buy any car because you can go and just call for a car and you don't need to own the car. Because when you own the car, you have to pay insurance. You have to go and fix it. You have to all that stuff. So if you need transportation, just call. Somebody will come and pick you up. That's the new model. So things will be evolving. Okay. Any other questions, comments? Okay. Well, before we take the last question, again, I want to thank all the audience for the people who actually came in person to attend the seminar, as well as the people online. And hopefully, if you're still interested in other kinds of technology, tune in for the seminar in October, probably October 11 or so. Okay, so let me take another question.
Oh, that's probably hardware question. Why is NVIDIA's so much different, so advanced for AI?
Because they're in slightly different area. They're all in AI, but NVIDIA is in the hardware portion of it.
Right.
So NVIDIA, no matter who develops the machine learning algorithms, who are all the professors working on the software and the algorithms part of it, everybody needs the hardware. So that's why I mentioned about all the machine training for the LLMs, the one that ChatGPT, the Microsoft, the Google, they all need the hardware to learn the information. And it just happens that NVIDIA's GPUs are the best hardware to do machine learning because they do things in parallel. The GPUs versus CPU, the main difference is the GPU, they can do parallel processing. So I mentioned earlier about matrix algebra. All the machine learning is actually vector. You have to deal with matrices, and GPUs are the best hardware to do that. So they're actually, if you look at the top, if you are investing into the stock market, you can buy some stuff in the software like ChatGPT or Microsoft. You can also still need to buy NVIDIA because that's the hardware part of it. Or you can buy a AI ETF where you have actually, it covers 20 companies and you don't need to go and sync your thing. So I would say, so I used to teach investing as well.
Yeah, I think that AMD also.
AMD is one of the competitors for NVIDIA, but that's on the hardware part of it.
Right, so they're all in hardware part.
Yeah.
NVIDIA say the new processor. When you order now, you have to wait for 1 year to get the part, right? So why not people just focus on AMD, and now AMD is so available, and why don't they develop something based on AMD?
Believe me, there will be other startups that will give a run for the money to NVIDIA, because now that everybody realizes how much money they are making,
right.
Do you think that everybody said, well, we're just going to let NVIDIA do get all the money? The thing is that it's all supply and demand. Everything in this world is based on economics. You look at the Ukraine-Russia war, people say, when it's going to stop? The answer is very simple. When one of the parties runs out of money. When there's no more money to buy the bullets and buy the missiles and the planes, they will naturally stop. Okay, so the same thing. NVIDIA today, it has the lead in time over every other competitor. AMD says, well, we don't want to fall behind, so we're going to give a chase to NVIDIA. So actually, the two CEOs of both companies are Chinese. So they both went back to Taiwan, say, well, you know, look at all the stuff. You know, some people say, well, great. You know, Taiwan is going to have all this, the hardware lead, because all the companies are both AMD and NVIDIA, their CEOs are Chinese. And so they say, well, okay, well, China is going to have a tough luck trying to catch up, because chips is not something that you can do overnight. Okay, but guess what? There will be other startups that will start coming up, because that's a market.
Is Intel coming in or no?
Intel? Intel, I never heard too much about. They're making a lot of inroads on the GPU. They are still based on CPUs, and they're still basically worried about the chips. But the thing with the GPU, the difference between GPUs and other stuff is in the architecture. It's not really on the semiconductor technology. It's that how you do things.
So maybe too late.
I think it's a little bit too late for Intel, because Intel is they did not bet on the right architecture. Unfortunately, when you make a mistake like that, you can fall behind by many years, because you say, okay, I'm going to, instead of picking a sports car, I'm going to go and drive a farm truck. Okay, well, it depends what your purpose is. Okay, so they were the leading company in terms of CPUs, and they never relinquished moving to other areas. As a matter of fact, if you think about it, NVIDIA was lucky. When they go and develop their GPUs, at that time, there was no machine learning. They were doing because of the games. And then they find out just by luck, say, oh, by the way, well, our GPUs are also good in doing matrix manipulation. So they luck out. So sometimes that's the way that life is. You know, sometimes the luck is actually more important than anything else. Okay, well, just to close the session, again, thanks everyone for coming. Okay? Okay.
Can we get a copy of this presentation?
Write me an email.
Okay.
bgao2k@yahoo.com. I'll send you at least some set of the important ones. Okay, yeah, my email is bgao2k@yahoo.com. If you want to have, I probably won't give you all the slides because it has graphs and pictures and everything, but all the key ones I'll give you to you. Okay. Okay. Just send me a ChatGPT email. That's a well written and so on.